S22, and so on and so forth. So let's go to the example. This is the example where it's asking that find the S parameter of this 3 dB attenuator circuit shown in figure this. So this is a T network where port 1 and port 2 is defined. So let's see and go to the solution, and let's see how we can solve this problem. Okay, to find out all the S parameters, first we try to find out the port 1. So the port 1 have, since this is 2-port network, so we have 4 elements. Port 1 have 2 elements, S11, S21. And the port 2 have 2 elements, S22 and S12. So let us find the S11 first. We know from the definition that if we want to find anything from port 1, we need to match the port 1 with the 50 ohm, not really 50 ohm, we call it, we need to match or terminate the port 2 with the characteristic impedance. In this case, this is 50 ohm. You can add 80 ohm, 60 ohm also, it's up to you, 100 ohm even. But you need to tell that how much what is your assumption. You need to tell, you need to declare first. Now by considering that this is 50 ohm, we will consider that port 2 is matched, and because of that matched, we have this as that what I have shown you already in the previous video, that the S11 is the ratio between the reflected voltage in port 1 and the applied or incident voltage in port 1, where the A2 is 0 at port 2. By this scenario, actually, this S11 becomes the reflection coefficient at port 1, which is actually equal to Z in minus Z naught. Z naught is this one, characteristic impedance, and Z in plus Z naught. So to find out S11, since this is equal to this one, so find out S11. We know already this one is 50 ohm, so we need to find out Z in first. So let's go and find out Z in, then we can find out the S11. To find out Z in, we need to look from port 1 towards port 2, while the port 2 is matched with 50 ohm. Now when we see this one, we can see that this 8.56 and 50 ohm is series, right? So this becomes 58.56, and then this one, the 58.56, is parallel with this one, isn't it? So the whole thing, this one is parallel with this. So this parallel with this will give you somehow like this. This is a normal circuit operation. If you really don't know, later on I can discuss about it. I can put up another video of how to do it. But I assume basically this is circuit 101, so I assume that you know it already about. So this one added with this one completes the whole network. Okay, so this is what our Z in here, which is actually, if you calculate this one, you will get exactly 50. So from here we find out that this is 50 ohm, this is 50 ohm, this is 50, and this is 50. But this is 50 minus 50 make it 0. So this means that whole thing becomes 0. So S11 becomes 0. So thus the S11 becomes 0. Similarly, this is your task that you need to do. You need to terminate here with 50 ohm. Disregard this one. So the whole thing comes here, and this comes here. So this is 50 ohm, and when you look at here, you will find the same 50. That's how you will get S22 is 0 also. So we get two elements, S11, S22, S0 and 0 already. Now we need to find out which one is S21 and S12. So from the definition, we know that S21 is equal to B2, means the reflected voltage at port 2 and the incident voltage at port 1, where the A2 is equal to 0. So here it's written here, you just read about it, you will understand. So it's still, this is the same circuit where A2 is 0 means the A2 is the V port, the port 2 actually is matched with 50 ohm. So we go to the solution now. So if we know that S11, S22 already 0, then there is no reflection at port 1, right? So no reflected voltage. Since this is a reflection and the reflection coefficient is 0, means there is no reflection. So the B1 is equal to 0. So from, if it's B1 is equal to 0, we know that V1 voltage, the total voltage at port 1 is the incident voltage plus the reflected voltage, right? So if B1 is equal to 0, so V1 becomes A1. Similarly, if A2 is 0, then the V2 becomes B2. Remember, these two will help us to derive later on. So we know that B2 is equal to V2, right? So from S21 definition that we already know about it, here we derive this one. We know that B2 divided by A1. So let us try to find what is B2, then how we can cancel this A1 also. Now with B2, we just know that B2 is equal to V2, right? Which is this one, V2, the voltage across the termination, the 50 ohm. So how we can find it out? Okay, we can find it out. It's not so complex way. We need to find out that how much voltage across this one first. Okay, and then we consider this whole network come on this two port, and then this is like this is the input of the whole circuit, right? But this volt will distribute in here and everywhere, isn't it? So in terms of V1 we will find out the V2. However, we need to bring what is the voltage here first in terms of V2. So to bring that, we need to find out that what is the total resistance of this network. The total resistance of this network, actually we already find out that this is like this, that this one, this parallel with this, and then this is series, right? So this one, if you parallel with this series connection, it gives you 441.44. Now since this voltage is here, you make a voltage divider. Once you have a voltage divider rule, then it becomes, because this is this voltage you're going to find out across this one, so it comes 41 multiplied by V1 divided by 41 plus this. So now we know that this whole voltage is here, isn't it? So now this voltage is as an input of this network. So to find out V2, we need to make another voltage divider across the 50 ohm, is this with this. So since this voltage is here, this whole voltage is here. So we use 50 multiplied by the whole voltage divided by 50 plus this. So that's how actually we got this whole. So in terms of V1, as we know that V1 is equal to A1, so we put A1, and if you calculate this one, you will get this. So from here, if you put this one as B1, B2, then A1 and A1 cancels out, and we get S2. 1 is equal to 0.707. Similarly, if we do the same scenario here and we watch from here, we get the S12 is equal to 0.707. So that's how the whole process has been done. So we know now that this is the voltage here. So this is the summary of the whole thing. So we get 0, 0, and this is 1 over 1 over root over 2 means actually 0.707. So that's how we find it out. So we move on to if you have any difficulty to understand this one later on, you can contact me I can, or maybe later on I will upload another supporting video how to analyze this one in terms of this way. But for you to understand first, if you cannot understand, later on you request me, I will upload the video. So this is the summary of the whole situation. So you try to understand it also. Here it's more elaborately described. Now moving on to one more example, that we learn about the reciprocity, the symmetry, and is it lossless or not. So in this example, we will try to find out that is this network is symmetric, or is it reciprocal, or is lossless. So first we find out this network is reciprocal. Determine if the network is reciprocal and lossless. Part two is terminated with matched load. What is the return loss and the loss seen at the port 1? And if the port 2 is terminated with the short circuit, what is the return loss seen at port 1? Okay, let us find first the A. So as we know already that for S matrix, it's not symmetric and not reciprocal. How you know it? Because this is not equal. If this 2 is equal, then this is reciprocal. So this is not equal, isn't it? So if this is not equal, so this is not symmetric also, because this 2 is not equal also. So this is not a symmetric and not a reciprocal network. But let us try to find out whether it is lossless or not. So if you try to find out this one, so from here we find this and this, isn't it? This and this, I think. Yeah. So this 0.15 plus square plus 0.85 square, it is not equal to 1. So it means this is not a lossless. Now we go to the second part, B. If the port 2 is terminated with a matched load, what is the return loss seen at port 1? So if it's matched load, then in the previous example already we say that if it's matched load, then S11 is actually the reflection coefficient. So the reflection coefficient gamma is equal to 0.15. It's here. So we find out that RL, the return loss, is equal to minus 20 log of the reflection coefficient, and then we got 16.5 decibel dB. Now to the third part, if the port 2 is terminated with the short circuit, what is the return loss seen at port 1? So if we go to short circuit, then there is no incident voltage. So all the V2 will be considered and changed to V2 minus. So here from V1 is equal to, from this parameter matrix we get this, right? So this all is considered V2 minus and V2 minus. Then if we equate this one in terms of V2 minus, we get this one. So now we know the values here. Okay, so if we put this one here, so V2 minus and divided by V2 plus is equal to actually the reflection coefficient. So this one is equal to S11 minus, try to see, S11 minus this one. So from here actually we are getting this one. Now you're gonna put the you know all the values, right? So S11 minus S1221 in terms of this we get from here until here. So from here we get this one, and then you need to use both of the equations actually to equate to get this one. So from here we get S11 minus S12 plus multiplied by S21 divided by S1 plus S22. So by putting all those values here, we got here these values, you get here, and then you get this one. You can use, better you not use this one. My recommendation is, and you will get possibly this value. Try by yourself. If you have trouble equating this one, we can talk about it. So the return loss, we already find this one is minus this one. So the return loss, we found out this. So you cannot use the negative here, because see this. So the absolute value of this one is not minus. This is 0.452. So you use 452 and this one. So there are some important points I have listed here. So you read about it to grow some basics about it. So later on that we can discuss about it if you don't understand. And this is some examples. This is not mandatory example, but I just given this one to for you to understand later on. Do it by yourself. Try to analyze the circuit, and then do this one. This is your homework. I will add some suggestions, some numbers exercise from the book, and then you will do those things, and later on maybe we will have a test on this one, on this 3 lectures, and then it will be included in the final exam. So I hope that you have understood all the things, and if you have any trouble you can get back to me, and if you have problem with calculation or understanding anything, just get back to me and ask me. I will try to help you. Thank you so much for patience. This is the last lecture of the 3 lectures of network analysis. Assalamu alaikum wa rahmatullah.